Today we're going to do an in-class review for Excel 3.
You need to practice some of the property, including the beginning parts over here. If you see k is a number and you're taking integral of it, that would end up with what? If k is a number taking an integral, then it will equal to, it's similar to number 1 here. If it's taking integral of 70, that would equal to what? And an x there, and also we need what? One more thing. C. So it would be like 70x plus the c, right? So same thing with the property on the top with a. It's the same as this. So 70 is a number, so you stick an x plus a c. K is a number, so it would be what? Pretend k is 70. Kx plus c. So you will have something like this on the test also. We will ask for the property, so you need to be able to tell if k is a number, just add an x back plus c. All right, the next one is not taking the integral, but if you have a number and a function dx, then the number go where? Go up front, so pull the k out. And then you will take integral of the function dx. Is it okay? So the first part, just testing your property. When you have x raised to n, then it would be what? Start with a fraction. The fraction have what? 1 over n plus 1 in the denominator times x, and then n plus 1, and also you need to add a c, right? So it's an indefinite integral like that. Okay, how about e to the x? When you take integral or derivative of e to the x, it will equal to e to the x. See? So please review this. And 1 over x will turn into ln of x, absolute value, adding c. Okay, the last one is not really taking integral, it's just the next step. If you have two functions adding together, we can do what to them? Separate them, so you can take integral of f of x dx, adding integral of g to g of x dx. Okay. B and F is not really taking integral, it's just showing you what the next step would be. So this is the next step. This is the next step. So the top part is just property. If you take a constant, you will put an x as c. If you have a number with a function, pull the number out. This is not taking integral yet. If it's x raised to the n, it would be 1 over n plus 1. X raised to the same power. Integral of e to the x is just e to the x. And 1 over x take integral would be ln of x. And if you have add and subtract in between two functions, you can break them and take them individually. Question for that? Okay, let's look at the next part. Next part is applying to those property. So the first one is just number. So just now we say just put an x with it as c, because this is indefinite integral. Number 2, what do we get?
Ex plus c.
E to the x plus c. And then the next one have a number in front of it. So first we will do what? Pull the 8 out, pull the number out, and then taking integral x to the 10 power dx. So for that, we are going to do what? Like x stay outside, and then for x to the 10 power, following this property, we will do what? Multiply. Okay, this is the same as this property. 1 over 10 plus 1 in the denominator, and x also raised to 10 plus 1, right? So this will have what in the denominator? 11. So x going to go to the top, 11 go to the bottom, and then this is x raised to 11 power, and don't forget, which I forgot on this step, 2 plus c. So indefinite integral, you need to add c there, okay? Next one, we have this. I can rewrite this as what power? X raised to a forward will become what kind of exponents? 1/4 power dx. So if I'm taking integral of them, first I will have, again, same property as c.
1/4
plus 1, which is 4/4, and then x do the same thing, right? 1/4 plus 4/4, don't forget SC. So now in the denominator, we are going to have 1/5/4, and then x raised to 5/4 plus c. When you have a complex fraction, how do you simplify it? You divide, meaning you just need to flip it. So 4/5 x 5/4 plus c. When you have a complex fraction, it's 1 divided by that. Division turn into multiplication. You're supposed to flip the second fraction. So the easiest way to think about it, just flip it. Okay? All right, let's look at the next one. We have 1/x. When you take integral of 1/x, this will turn into ln of absolute value of x. Don't forget to add c. That's all. I have another one of this, I don't know why. So let's do one more. So if you have x raised to 21 power, then you will have, start with 1/21 plus 1, that's why we have 22, and then x raised to 21 plus 1, which is 22. Don't forget SC. You got 1/22 x to the 22 power, adding c. Are we okay with the first page? The first page is all the basic properties, so please review as much as you can. The next page will start question with a little bit more complex properties, so you may need your own paper. It's not going to have enough space there. We're going to look at number 7. Number 7 is definite integral. We are taking integral of 1/cube root of x minus 5/x to the 4th power. For this, I probably want to rewrite them as exponents. So the first one, 1/x to what power? If you have one cube root, that can turn into what kind? 1/3. Because you have an invisible 1 inside, this turn into fraction 1/3 power minus 5 times, this is x to what power? If it's in the denominator, this will turn into what kind? -4, and then the whole thing dx, right? If you want to, you can break them into individual terms. You can take this and take this. Let me write one more step. So if the first one in the denominator mean instead of 1/3, this would be what kind of exponents? -1/3. And then dx minus, this is, we can put a 5 out. In here, we have x raised to -4 dx. So from the beginning, this in the denominator is a negative exponent, -1/3. For the second one, the 5 can go outside. In the denominator will be x to the -4. So taking integral, the first one will start with what? The fraction is going to be 1/(-1/3) plus 3/3. Do the same on the exponents for x, -1/3 plus 3/3, right? And the next part we have subtracting. This would be a 5 with the denominator is what? Denominator, you will put the exponents down at 1, so you have -4 plus 1, and then x will raise to -4 plus 1, and then don't forget to add c, right? So this is number 7. Okay, so let's clean up the fraction part. 1/what? 2/3. This is x raised to 2/3 minus 5. You can put a 5 outside, but that part is just the denominator. So 5 over what? -3, and x also weighs to -3, and then need to add c, right? So earlier we said when you have a complex fractions like this, what do we do? Flip it. The easiest way to think about it is it's going to turn into 3 over 2, right? But don't change the exponent for the x. This is going to be x raised to 2/3. And then this one is negative times negative will become positive. 5 over 3. The x raised to -3 power go where? At the bottom. X to the third, and then adding c. You can leave it like that, or you can write this as the radical, which would be 3/2, and then x. This is a cube root of square here plus 5 over 3x cubed plus c, but this is going to be fine. The first page we have the basic properties, so make sure you practice it very well. So starting number 7, they are more complex. Okay, let's look at the next one. Number 8, we are taking integral of e 15x dx. We will consider the exponent. It's not? I think when I send it to the printer, it's not a PDF, so some of the thing may be missing. So let's everybody look at number 8. Can you add an x for me? Somehow it's missing the x. So make sure number 8, the exponent, you have 15x here, okay? That part will be considered as the chain rule, the 15x. So last time we talked about it, if we let u equal to the exponent part of e, so u equal to 15x, right? So we need to find du. Du is going to be what? 15 dx. And I don't see a 15 here, so this 15 need to go. How do I get rid of that? Divide both sides with 15. This is 1 over 15 du equal to dx. We're going to need to use this along with what is u to substitute this. The 15x is my u. And then the other part is dx, which is this part. So I'm going to substitute with u, which is integral. We got a e here, and 15x is u, right? And the dx part will be 1 over 15 du. This is substitutions. So 1 over 15 can go outside, right? Because it's number. And then we are taking integral of e to the u du. E raised to some power taking integral is just going to become what? E to the u, didn't change anything, and then add a c, right? And the u is what? 15x. So we just need to put it back. 1 over 15 e 15x plus c. That is how it works for the substitutions. There is a shortcut some of the students like to use. I'm just going to talk about it briefly in case that interests you. This only works for the integral of e raised to a function dx. The way it works is it will become 1 over the
Take the derivative of the function
and then e raised to the functions adding c. So this is considered a shortcut because you don't have to do substitution at all. So we can double check and see if this is correct, okay? So remember this is the function 15x, f prime of x in the denominator. So it's going to be the 15x need to take the derivative, so it's 15 here, and then the function is, let's go here. So for me, I usually use the substitution. So do number 9. So number 9 is also a substitution question. This is substitution. How do I know which part is my u?
The one with the bigger power.
The one have higher power, that's a good guess. So let's try this. If I let u equal to 3x squared minus 4x plus 1, then du will be what? Taking the derivative of that. First term is
6x
6x
minus 4
Good. The whole thing dx, right? Okay, so I compared this with the top part. Does it look kind of similar? But what? I need to pull out a 2. So if I pull out a 2, this is a GCF. Inside we'll have what?
3x minus
Which match this guy, right? But this 2 is extra, so these 2 need to go. Divide by 2 both sides. This is 1/2 du equal to 3x minus 2 dx. The part that you use to substitute, including the u part, and also the dx with the 3x minus 2, this part. So I'm going to put them in order for you to easier to see which part you're substituting. The first part is your u, which is 1 over 3x squared minus 4x plus 1. And the top part here, you got 3x minus 2 dx. Okay, the denominator part is your u. And then the top part is your du, 1/2 du part, right? So this will turn into 1 over, this is my u, and this part is my 1/2 du, right? Because 1/2 is a number, so where does it go? Outside, so you're taking integral of 1 over u du. And 1 over u will turn into ln of x, so 1/2, and then ln of absolute value of x. This is indefinite integral, so you need to add a c. So, I'm sorry, this is u, right? It's supposed to be a u, not x, because we're doing 1 over u. So ln of u du, sorry, ln of u here, so u is what? This part, right? So we need to substitute back. So this is going to be 1/2 ln absolute value of 3x squared minus 4x plus 1 close the absolute value plus c. So this is substitutions. We set the higher power part with u, find out what is du part, and then substitute and take integral and substitute back. Okay, so it's going to need some practice, and you have one like this on your quiz also, so use that to practice also. So starting number 10 is definite integral, meaning you have the lower limits and also the upper limits. Number 10, we have the definite integral from -1 to 2, taking integral of 6x squared plus 10x plus 5 dx. This particular one does not have a substitution because it's just individual terms like that. We need to take the integral and then plug in the upper limits, subtracting the lower limit. Okay, plug in the upper limit, subtract lower limits. So the first term is 6x squared. 6 go outside, right? You're basically just taking integral of x squared, which will turn into what?
1 over 1 plus 2.
2 plus 1, okay. And then x also 2 plus 1, right? And then the second term, 10 go outside, and then the x part would be what? 1 plus 1, and then the x do the same thing, right? And then the 5 just need to do what? 5, stick a x there, that's it, okay? We can add a c, but because it's adding and subtracting, the c always get canceled out for the definite integral. So if you don't want to mess with the c, that's fine. Once we take the integral, we put it in a brackets and put the upper and lower limit at the end. This is the notation, okay? So the first term is 6 times 1/3 x cubed. Second term is 10 times 1/2 x squared plus 5x, right? And this whole thing, later on, we need to do the upper limit, subtract the lower limits. So simplify those fractions. What's the first term? 6 divided by 3 is 2x cubed plus 5x squared plus 5x, need to plug in 2 and then subtract the whole thing, plug in -1, right? So I'm going to do it on the next step. 2 times something cubed plus 5 times something squared plus 5 times something, the whole thing, subtract the second part. Same thing, 2 times something cubed plus 5 times something squared plus 5 times something. And the first part put in what? The upper limit 2. The second part plug in lower limit -1, -1, -1, right? So now, if you like, you can plug in the whole thing in the calculator. That would be fine with me. I'm just going to write a little bit more stuff for you in case you're confused. 2 times basically 8 plus 5 times 4 plus 10. Need to subtract. This is 2 times -1 plus 5 times 1 minus a 5. And we need to combine all this number together, right? So this would be 16 plus 20 plus 10, I think. Subtracting in here, we got -2 plus a 5 minus a 5. So these two numbers cancel. We will get this few number add together is like 46 plus the 2 is 48. So this is just adding number together. So once you get to here, upper limit plug in, subtract the lower limit plug in, and get the number. Are we okay? So far what we have done, quick recap. Again, the first part of the property, make sure you practice the basic property, make sure you know how to take the basic integral from the first page, and then we start taking indefinite integral, which is a little bit more complex, and then we have substitution with the u, and then now we're doing definite integral. You have to plug in upper and lower limits. So let's look at number 11. We have from 0 to 2, 2x, x squared plus 3 squared dx. Do you think I need a substitution or not here? Number 11, does it need u? The part that weighs to some power, right? So we're going to let u equal to the part weighs to some power, which is x squared plus 3. So du is going to be
2x.
That's it, right? Dx, but don't forget the dx, okay? I have 2x dx, so do I need to divide 2 this time? A lot of time we divide by 2, right? No, we will keep that because I can substitute with that. So I'm going to put this part first because that's my u square, and then I put the 2x dx together. The u part is going to be this. And then the du part is this part, right? So we're going to substitute that. From 0 to 2, this is u squared. 2x dx is going to be my du. So I think we are ready to take the integral. This will become what? 1 over 2 plus 1 is 3, right? And then u weighs to 2 plus 1 also 3, right? And then normally we add a c, so I can show you if we add a c here, it's going to get cancelled out because we're going to plug in the upper limit, subtract the lower limit, right? So far, are we okay? Oh, I have a problem. I forgot one thing. I did the u, right? And then I have upper and lower limits, so I'm going to need a new u limit when we do that. So I'm going to need the new u limit when you do substitutions for the definite integral. Substitution means when you use u, right? The definite integral means you have upper and lower limits. So your old limit was x equal to 2 and x equal to 0, correct? And then if you need u value, then you will use the u equal to x squared plus 3. So u is going to be what? For the top one, 2 need to raise to the second power plus 3 is 4 plus 3 is 7. So the new u upper limit is 7. And then if x equal to 0, plug it in again, u equal to 0 squared plus 3 will give me the new u lower limit is 0 plus 3 is 3. I'm supposed to be, when I put in the u, I need to also change the limits from 3 to 7. Once you substitute with u, you also need the new u limit. So after we take integral, then 7 here and 3 here, right? And that happened a lot on the test also. People forget to change the new limits. We are going to plug in the upper limits, which is u to the third power plus c, and then subtracting the lower limit part, 1/3. The u need to raise to the third power plus the c here. The first one plug in what? 7. The next one plug in 3. Okay, so 3 to the third power is going to give me 343 on top. At the bottom we have 3, adding a c. And then on the second part, we are going to have 3 times 3 times 3, which is 27 over 3, plus the c. This is same denominator, maybe we add it together first. So I'm going to keep that as fraction. 343 over 3 plus c, subtracting 27 over 3. And then don't forget, distribute the negative to the last part. That's how your c got cancelled, right? Okay, so if you add these two fractions together, what do we get? The denominator is 3, but the top will be what? 316, so that would be your answer, okay? So when you take integral, you're basically finding the area below the functions of the line. So this is a substitution, but it's also a definite integral, so we need u du. And don't forget to find the new u limits. So this is a very common mistake, I almost forgot. Plug in the new limits, then we take integral, use the upper limit plug-in, subtracting the lower limit plug-in. So that's how you find the definite integral. Okay, that's one example. Number 12 is going to be finding the area under the functions y equal to x squared plus 10 from x equal to -1 to x equal to 2. This means I'm finding the integral. When they find area under the curve, it's going to be integral, and that would be your lower limit to the upper limit. This is the lower limit. This is the upper limit. Let's do the integral. Lower limit is -1, upper limit is 2. The function is x squared plus 10 dx. When you take the integral of a function, you will get the area under the curve. Take this integral. The first term is going to be what? X squared will become, it's going to be 1 over 2 plus 1, which is 3, right? And then x raised to 2 plus 1, which is 3. And then the 10 will become 10x. And this time we don't need new limit, right? Because we didn't do any substitution. So -1 is the lower limit, upper limit is 2, right? So this will turn into basically 1/3 x cubed plus 10x, right? And then I can plug in the upper limit, subtracting the lower limit part. Is that okay? So the first part we have 1/3 times something cubed plus 10 times something. This whole thing, we'll need to subtract the lower limit part, which we plug in the same thing, 1/3 something cubed plus 10 times something. The first part we're going to plug in what? 2, which is my upper limit, right? And the second part we're going to plug in -1, which is my lower limit, right? So now if you are good with calculator, you can plug in the whole thing in the calculator. It will not bother me. But this is going to be 2 cubed, which is 8, right? On top, 3 at the bottom, plus 10 times 2 is 20. And then the second part, we are going to have subtracting. This is -1 cubed will still be -1, right? Over 3. And then this would be minus a 10. And don't forget to distribute that negative in there, okay? So we're going to have 8 over 3 plus 20. Distribute in there, become positive 1/3. Distribute in there, become positive 10, right? Combine them. The two fractions combined together will give me 9 over 3, and then the number is plus 30. It's going to be 33 because it's 3 plus 30, right? Equal to 33. Are we okay finding area under the curve? It's basically taking integral and just use the lower limit to upper limit.